Drainage innovation at the Huronview Demonstration Farm. Environmental monitoring on the farm. A closer look at tile flow. To answer the 4 questions mentioned in the introductory video, can controlled drainage improve water quality? Will splitting tile double the drainage? Could contoured swales or terraces work here? And how much will a wetland filter tile water? We need measurements and data. The Huronview Demonstration Farm is monitored for both water quantity and water quality. Through analysis, we can turn this data into information that will help answer these 4 questions. This video, a closer look at tile flow, will focus on water quantity, the term we use to summarize the various aspects of water flow. In simple terms, water quantity is the collection of flow data and can be used for determining water volume. Both water quality and water quantity have their own processes for deploying equipment, collecting, maintaining, and processing data, with water quality having the additional step of using a lab to conduct analysis and reporting the concentration of nutrients for each sample. This video will focus on water quantity, the equipment needed in the field to record these measurements, as well as the data processing that goes on behind the scenes. To obtain water quantity measurements, a dedicated monitoring spot must be located where there is flow that can be measured. To contain the water and help with recording measurements, additional structures are needed. At Huronview, surface water is measured using V-notch weirs. These weirs are placed on the flow path already seen in the fields from natural water movement over the years. These weirs intercept the water and direct it through an inverted triangle. The V-notch is a recognized practice used for concentrating the water and measuring flow. The pictures on the left represent the surface monitoring structures at Huronview. Tile flow is measured in agri-drains, which act as surface access points to the tiles underground. Tiles themselves already act as a container for concentrating flow. However, a V-notch is also included in the agri-drain monitoring well for improved accuracy and flow readings. The picture on the right shows the top of the monitoring agri-drains used for the tile sites. The top sits about 1 foot above ground level. Each surface weir and agri-drain that measures flow is equipped with a level logger. These loggers do not measure flow, but are able to measure stage, or in other words, the height of the water in meters as it continues to rise. Level loggers are very versatile and can measure water level on the surface and in tiles, as well as the fluctuating height of a wetland or the water table as it moves up and down in the soil. Because of their versatility, the Huronview site is currently using 22 level loggers to record water level movement throughout the farm. Stage data is stored in a computer chip within the level logger, and using additional equipment and software provided by the manufacturer, these level loggers can be downloaded to retrieve the data. Data at Huronview is logged every 5 minutes for tile and surface water. Water level height in the wetlands is recorded every 15 minutes, and for the slow up and down movement of the water table, loggers record data every hour. Loggers are downloaded every 2 to 4 months at Huronview depending on their logging interval. Once the in-field procedure of downloading the loggers is complete, the data is brought back to the office where it is stored and graphed. Graphing the stage data helps to identify rain events, because as it rains, more water enters the tiles and the height of the water increases in the agri-drains. This is true also for the surface water in the weirs. On the graph, these rain events appear as hills with a rising portion, a peak, and a falling portion. We refer to these graphs as hydrographs. Due to the nature of V-notch weirs, there will always be a time when water builds up behind the weir, but is unable to flow through the V-notch because it is held back by the material of the weir itself. Once the water reaches the bottom of the V-notch, the water becomes free-flowing. This is when we consider the water to have flow. Since the logger is able to record the height of the water as it builds up behind the weir, as well as the height of the water as it flows through the V-notch, we must separate this data into flow and no flow in the office. To convert the height of water into flow, an equation must be used. This equation has been provided by AgriDrain, the manufacturing company for these structures, and it is based on the angle of the V-notch and the height of the water h. When the amount of water surpasses the area in the triangle, water will flow over the top, and the equation changes to what is called a flat weir equation. This is based on the shape of a rectangle and not a triangle, but it still uses h, the height of the water. All these calculations are done in the office, and flow is calculated at every 5 mm height increment to produce what is called a rating table or curve. A rating table is essentially a chart that correlates the height of water to flow in liters per second. Once the height of the water has been converted to a flow measurement, rain events can be graphed in liters per second instead of meters. With flow measurements, more analysis can be done, such as determining the amount or volume of water that was produced during a rain event, such as the October 31st event you see here, or calculating the volume of water leaving each field. Flow is also needed for calculating loads, which is covered in another video. Essentially, loads can express the amount of a nutrient in a standardized way. Think kilograms of phosphorus leaving a field. If one field has tile water flowing at a different rate than another field, loads can help us compare the two. Calculating nutrient loads requires knowing what is in the water, which is the topic of the water quality video.